In this video, I'm going to show how to find the equation of the normal line to the graph of a function given implicitly. So to find the equation of any line, we can use the point-slope formula, for which we have to know one point and the slope. When we're looking for the equation of the tangent line, the slope is equal to the derivative of the function at a point. However, in case when we're looking for the equation of the normal line, we have to find the slope of the normal line, which is not equal the slope of the tangent line, but is related in the following way. The normal line, by definition, is perpendicular to the tangent line. That means the slope that I'm looking for and the derivative of the function at a point are the opposite reciprocals of one another. That means to find the slope of the normal line, I have to differentiate the function and find the opposite reciprocal of that, of the derivative at that point. Either way, I have to differentiate this function. So function is given to us implicitly. So to differentiate it, I have to use the implicit differentiation. So let's get started. So to differentiate this implicitly, I have to differentiate both sides. Now the derivative of the left side is just the derivative, the sum of and difference of these derivatives, and derivative of the right hand side is 0. So what's the derivative of x squared? 2x. What's the derivative of 2xy? When differentiating implicitly, we treat variable as a variable, and anything that is not a variable, we have to treat it as a function whose derivative is unknown. So when differentiating a product, we use the product rule, but x is a variable, so derivative of x is 1, but derivative of y remains unknown. So this is what the derivative of this product is. When differentiating a function multiplied by a number, we can factor out the number, and what's left is y squared. So to differentiate y squared, we have to keep in mind that y again is a function, so we have a composition of two functions here. So to differentiate it, we have to use the chain rule. So the answer is derivative of the outer function, which is the square. So derivative of the square is 2y times derivative of y, which is, we just write as y prime. So this is the result of the implicit differentiation. Now, since the goal here wasn't to find the derivative itself, but to find the value of the derivative at a point, instead of isolating the y prime, which is going to replace the x and y value of a given point into this equation, and then solve for y prime. So simplifying everything, so that means y prime is equal to 1. If y prime is equal to 1, that means the slope that I'm looking for of the normal line is equal to the negative reciprocal of that. So the slope is equal to -1. And now we're ready to write the equation of the normal line. It's going to be y minus 1 equals -1 times x minus 1. And we can write it in slope-intercept form by isolating the y variable. It's going to be -x plus 2. So this is the answer. To find the slope of the normal line, we had to find first the slope of the tangent line by implicitly differentiating the given function.